Hello and welcome to my channel. Now this video is going to wrap up the 4 in the line functions. What I'm going to do is now, as I was talking about before, I'm going to create a function that is just going to search here. It's not going to search, it's going to search all these things. And we're going to give it a color, for instance, red. Okay, it's going to look, can you find 4 in a line with red? But it's got to search all these moves. As soon as it finds a 4 in a line, it's just going to stop. Okay, and that's what we want it to do. And it says, yes, found 4 in a line. And that's it. That's all it's going to do. Now, we've got that converter function, and that's going to be very useful because we're going to use that, and we're going to loop this part of the board. So what I'm going to do is I'm going to paste the function in, copy and paste it. Okay, and I'll talk about it. So let 4 find equals 0. So what it will do is it will go through the playboard, and then because we got this convert to, that is only looking at the playboard as I showed you before. If that equals to us, so that's what it do. If board equals to us, then it would look for 4 in a row. And then you remember that 4 in a row, it returns 4. So what it is, that's why I've got to hard code it to 4, because if it returns 5 here, or 6 or 7 or whatever, if it doesn't return the expected value, then it won't work properly. So that's why I had to make sure that it either returns 4 or 1. Or it could return 4 or any other number. So if find 4 in a row equals 1, found equals 1, and then it breaks out, it just stops. As soon as it finds it, it just breaks out and stops looking. So if it comes here, it finds it, doesn't care about if it's anywhere else. It doesn't really matter, because once you've found 4 in a line, you've won the game. It doesn't matter if you find 2 4 in a lines. Okay, so it just breaks out. So what it will do is if it finds 4 in a line, it will return 1. If not, it will return 0. Okay, and that's that. That's what that do. The code isn't that complicated. And now that that is done, I can finally do what I've been trying to do for the last couple of videos. And that is to do something that's called an evaluation function. Now, when we are a computer, they call it artificial. When you make it play chess and Connect4 or whatever game you want to play, it's called artificial intelligence. That means that it's not intelligent like how we are intelligent. It's just artificial. So what it really means is the computer's really dumb, and you do something in such a way to actually make it look intelligent, but really, so they call it artificial intelligence. It's not really intelligent. So what we need now, with all these functions, we can get an evaluation function on the board, as in who is winning. So because I've done all of these functions, I can now make an evaluation function easy. And I'll show you how it works. Now, if this 4 in a row cannot find a win, it returns 0. Okay? That's all you need to know. If it cannot find a win, it returns 0. So what we do is, if 4 in a row all board and the color which is red, if it finds a win, that means the win must be for red. Okay? So therefore it return 100. I'll explain what this means in a bit in case you don't know. If it finds a win for the opposite color, which is yellow, then it's going to return minus 100. So what it means is it's going to look at, it's going to get a board, it's going to look at the position of the board, and if it's a win, if it's a draw, it's going to return 0, which is this here. If it's a win for us, it's going to return 100. If it's a win for the other person, it's going to return minus 100, because obviously Connect4 is a zero-sum game, meaning when I'm winning, the other person is losing, or if I'm drawing, the other person is drawing as well. Okay. Now, when you're doing these when you're doing these things like this, obviously these 4 functions that I've done here now, these are going to be used in the game quite a lot. So really, I should try to optimize them. Let me just have a look. Can I optimize this? I could optimize this, because the reason why I could optimize this is it's after a certain amount of squares, it doesn't have to. So, for instance, it doesn't have to loop through all the squares, because once it gets to here, once it gets to 59, if it hasn't found 4 in a row, then it doesn't have to check 60 and 61. But I'm not going to bother with that. I'm going to leave that. But this one here, this thing is quite fast. But anyway, I'll tell you what it is. I don't even have to use it, but I'll just tell you what it is. It's called XOR. So if you really want to know what it is, go to Google and type XOR truth table. And there it is. So what it says is, look at the 1. If 0 and 1 gives 1, and then that is 1 and 1 gives 0. That's the XOR truth table. So what this thing means is XOR. So can you see? So if I do 0 XOR 1, that is going to give 1. And if I do 1 XOR 1, that's going to give 0. So it's just flipping a bit. And it's quite fast. Now, as you can see, red is 0, yellow is 1. So what that does is, it allows me to check the board with 1, check the board with yellow, check the board with red. Okay, so if I put yellow in, it's going to check yellow, check red. If I put red, it's going to check red, then it's going to check yellow. Okay, and all that's going to do is, if I'm red and it checks there, it hasn't found it. It comes back as he didn't find a win for me, so it's not going to do anything. Then it comes here and it's found a win for my opponent, so therefore my score is minus 100. Okay, so all of this was just so that we can come to the board and get an evaluation function. Now this function, I'm going to leave it simple for the time being. However, we could make it a bit more complicated, and I'll tell you what I mean by that. Let me just do some, whoops. Let me just do something. Let me just change this a bit and I'll tell you what I mean. Okay. Now if I start a game, the computer's gonna say that is a possible move. It can't move here because we're playing Connect4. Okay, remember the counter drops down, so when we drop a counter here, it's gonna land on here. So that's possible, that. So the computer would have 7 moves to make. Okay? So what it would do, you'd look at move 55 and it would do evaluate for win. And the score's gonna come back 0. So it's gonna say, what's the best move? The best move so far is 55 and the score is 0. Okay? Then it will move to 56. And then you'll say the score is 0 there as well. Because obviously For it to find a win, it would have to look quite deep. So what it is, did it beat the best move? The answer is no. So it would leave the best move to 0. Then it would come here. Then it would come here. Come here, here, here. So in the end of what would happen is its first move in this position, unless I had if I had a super fast computer that could calculate all the way to the end, then it wouldn't play this. We'll see that this is the best move, and it will play this. But because of the limited resources, it would look to a depth of say 12, and it will think that this is the best move because none of these moves beat it. Okay. So if I wanted to make the evaluation function a bit more complicated, what I could do is I could give it a bias. For instance, I could put this middle square. I could say, okay, the evaluation function, if it's a middle square, add 1 to it. So when it comes here and it returns 0, it will say, is it a middle square? No. So the answer is 0. Come here, 0. Come here, 0. Come here, it will be 0. Is it a middle square? Yes. So it add 1. So that the score will be 1 here. So 1 would be the best score. So therefore, it will be biased towards moving towards the 1. Okay. Or I could even set that to 2, and I can set that to 1, and I can set that to 1. So that will give it a bias. It will give it a bias towards the middle squares. But I'm not gonna do that at the moment. But that's an example of a more complicated evaluation function. This one is quite a simple one. It's just gonna do plus 100, minus 100, and 0. Win, lose, or draw, and nothing else at the moment. Okay, thanks for watching the video. Until next time, bye.